A formula is an equation that depicts a relationship between, it can be between a lot of things, between variables specifically, but it just depicts some kind of real relationship that happens in the physical world. For instance, the volume of a sphere is with the radius r can be written using this. We only need to know the radius of the sphere to know what the volume is. Now, if we have the volume of a sphere, we're asking what is the volume if we have a radius of 2.3 inches. Well, all we have to do is take this formula and plug in r equal to 2.3. So we have 2.3 cubed plus 2.3 cubed. And if you look on the inside, so we're going to leave the volume on the left-hand side the way it is. We're not going to do anything with it. We're only going to work with the right-hand expression. And we're going to simplify this expression down all the way, solve for an actual number. And as you can see, on this right-hand side, we have these two portions. Now, 2.3 cubed, 2.3 cubed. This is actually like terms. It may not be clear. It's actually a bit clearer here in this expression here. We have r cubed and r cubed. Well, that's the same thing as saying 1 over 3r cubed plus 3 over 3r cubed, just making common denominators there. That's the same thing as 4 over 3r cubed. And so always keep in mind this idea that you can simplify things down as long as there's like terms. In this case, let's just keep going with this, with how this is written. We have to do exponents first, of course. So these two things must be done first. So we get 1/3, and 2.3 cubed is 12.167. One-third of that is going to be a bit of a long number, so I'm actually not going to do that. I'm actually going to write this as 4/3 times 12.167. And I'll show you why at the end. All I've done there again is just wrote this as this over 1 and multiplied by 3 over 3. I'll do it on this side. And here we have common denominators of 3. So we have 1 plus 3 is 4 over 3 times this number. I've just really used this thing and I've just plugged it in here for r cubed. Okay, let's keep going. I'm going to, everything here is just multiplying. The parentheses, right? Distributive law does not distribute over multiplication. So really all that's happening here is I can rearrange this thing and just say multiplying. It's the same exact expression. So what I'm going to do is I'm going to write it as 4 times pi over 3 times 12.167. And I'm writing it this way because this is a common way of writing a pi term, or I should say a pi factor with a fraction in it. But also this statement here is exact. And if I were to do anything else to this thing, it would become non-exact. I'd have to use an approximation. I'll show you that by actually calculating this thing out. And I get, I'm going to do it like this, 50.9650104. And it continues indefinitely. Of course, we have to round this thing to something like 50.97. But this answer here is exact, whereas this one is not. Even this isn't really an exact because we have to have this ... It's better to have the exact answer in the terms, but that's just kind of a minor thing. If you want a rounded answer, just calculate it out and round it out. Okay, another formula that we can have is the cost of gas. The cost of gas C, if we are driving D miles, average mile per gallon, the rate that you travel at, that your car gets, R, and with a price per gallon P, is this formula right here. C equals D over R times P. So if we are driving 152 miles and we get on average 29 miles to the gallon, and we have on average again $3.43 per gallon, how much does it cost? Well, all we have to do is go C equals, and then once again, we're going to leave C on the right-hand side, or sorry, the left-hand side. We're just going to leave it, not touch it at all. On the right-hand side, we know what D, R, and P are, so we're going to plug them in, and we're going to solve that expression on the right side. So D is 152 over R is 29. P is 3.43. This is all multiplying and dividing, so it can be done at the same time for order of operations. So I'm going to do 152 divided by 29, and then multiply that by 3.43. And because this is a cost, we're going to round this to 2 decimal places because our number system is 2 decimal places. And I get approximately $17.98. So that's how we can use that formula. Give it a try in number 6. Okay, the potential energy of an object with mass m kilograms and height h meters above sea level, of course, is this expression here, this formula. And the energy that we're going to find is measured in the unit joules. Okay, what is the potential energy? That's what we're talking about here. With mass 2,300 kilograms, and that is a height of 10 meters off the ground. 9.81, if you didn't know, 9.81 is actually the acceleration due to gravity. It's in meters per second squared. This is from gravity. Okay, so this is quite simple again. The energy, potential energy, that's going to be left the same. We're not doing anything with the left-hand side, but 9.81 times the mass, which is 2,300 kilograms, times the height, which is 10 meters. Okay, we can go ahead and solve this. This is all multiplying, so no need to really worry about order of operations. 9.81 times 2,300 times 10. That gives me 225,630 joules, capital J for joules. All right, try out number 7. A classic formula is the Pythagorean Theorem. I definitely hope you've seen that before. It just relates the 2 legs of a right triangle. So we have a right triangle here. The hypotenuse is always opposite of the right angle. So this is the right angle. Going opposite that is the hypotenuse C. And the 2 legs can be named A or B. It doesn't matter which one's which. Just name them. And then we can use Pythagorean theorem to solve for any one of the sides. If we don't know what the hypotenuse is, then we can actually translate this formula into this one by taking the square root of both sides, and that'll give us the square root of a squared plus b squared. That equals the hypotenuse. So using this formula, a is 12, b is 5, 12 squared is 149. I have to do, sorry, 144. I have to do these exponents first before I can do anything else. 5 squared is 25. The square root symbol is a grouping symbol. That means I need to do the addition first before I can do the square root. 144 plus 25 is 169. And the square root of 169 is 13. This is actually called a Pythagorean triple, 5, 12, 13. It's called a Pythagorean triple because it satisfies Pythagorean theorem. A, B, and C, a squared plus b squared equals c squared. Another Pythagorean triple is 3, 4, and 5. You can test that one yourself by plugging in for A, B, and C into the Pythagorean theorem. Okay, with this in mind, give it a try on 7, 8, and 9.